While we get the PowerPoint up, my name is Jeffrey Lipton. I am from Cornell University's Creative Machines Lab. I'm also with the spin-out of the Creative Machines Lab, Seraph Robotics, which sells bioprinters. And today I'm going to be talking about 3D printing and its applications in the food markets. I'm going to start with an overview on 3D printing. I'll move into motivations for the use of 3D printing, applications for food-related devices, and then 3D printing using food materials.
Okay.
Thank you.
Isn't this the remote?
So what is 3D printing? 3D printing is a very broad category of adding material layer by layers to produce an object. There are literally dozens of processes that fall under this umbrella. Some use plastic and filament on a robotic arm, like this video here, or not. And others use powder beds, others use all kinds of different things, and it's found applications in dozens of industries. So here we find in the fashion industry, it's been used to produce high-end artistic goods. For instance, this shoe stem here, a lot of jewelry that's custom made is done using a 3D printer, using a lost wax process, and even this entire dress was entirely 3D printed out of plastic. And recently, the big US star Lady Gaga, a lot of her wardrobe is starting to be 3D printed, so it's having impact there. It's been widely used in architecture, mostly for model making for a lot of its history, but now it's starting to find its way into direct fabrication of buildings. So this is actually an entire room that's been 3D printed. And now innovation in Italy and actually right here in China is leading the way to 3D printing entire homes. So this building right here is entirely 3D printed structure made out of cement. And it's found use in the medical industry. So the 3D printing industry has had a lot of experience getting used to safety concerns for medical applications, specifically in hearing aids, medical implants, for cranial reconstruction, and for hip implants. And so the 3D printing industry really has the know-how to start of work with highly regulated industries. We've also been seeing an explosion in the 3D printing of human tissue. This is Larry Bannister, and he's holding right here is a human ear that's entirely 3D printed. It's actually a copy of his daughter's ear. And right next to it is a human heart valve. It's kind of hard to see behind this defect here, but it's a fully functioning human heart valve we hope to have implanted in the next few years. And currently, the application in this area that you could see coming towards the food industry is toxicity screening. The medical industry is already using 3D printing of tissues in order to produce 3D cell cultures, so you can do high throughput screening of chemicals. So now 3D printing can help you do better toxicity analysis for new chemicals by running them through 3D cell cultures that have been 3D printed. It's also been widely used in the aerospace industry to produce these complex parts. The one on the bottom left is a Chinese part. It's one of the largest titanium parts made in the world. The others, the top left is a bracket that's flying on Airbuses. The other one is the first 3D printed part to fly on an airplane, and it's currently flying in Boeing airplanes as a duct. And this one's from GE. It's one of their latest innovations to reduce weight, and they're all finding huge value adds from 3D printing. So 3D printing, you may be wondering, why are we talking about this? You know, the global manufacturing industry is 20 trillion US dollars. The Chinese manufacturing market is around 3 trillion US dollars. And that little corner right here is the, I had to put the white thing here so you could even see it, is the global manufacturing market of 3D printing in 2012. It was 2.3 billion. Right? It's very tiny, especially compared to the food industry globally, worldwide. So why are we talking about it? And the answer is it's having transformative impacts in all these industries I've mentioned. It's one of these technologies that, you know, creates a little bit of value for itself, but generates a whole bunch of value for its users downstream. And the interest in 3D printing has been exploding. So when I started work in 2009, this is the Google trend results, and you can see it's literally been an exponential growth in interest in 3D printing. And most of that is because in 2009, this is what 3D printers looked like. And this whole space down here, which should have filled out, is low-cost 3D printers, which are now coming out onto the market for $1,000, $2,000 in order to produce desktop-scale manufacturing. And the reason it's going so important is because 3D printing has some unusual advantages. It's actually cheaper using a 3D printer to produce a complex shape like this than this solid block. So complexity is relatively free with a 3D printer. You can mix multiple materials together. So this is work out of MIT where they blended different colors in a complex arrangement to replicate the structures in the human lung. And this is done entirely using a multi-material 3D printer from Stratasys. Also, costs scale linearly. So unlike traditional manufacturing where your first part costs you $10,000 because you have to make the mold and every part after that costs you $1, it costs proportionally as much to produce on a 3D printer 10 as 100 as 1,000. Which all in turn leads to low barriers of entry, right? It's very easy to kind of get started with a 3D printer because you don't have to build up all this tooling and dyeing, and you can do initial tests relatively quickly. And all of this leads us to seeing the killer applications of 3D printing as complexity and customization. You know, the classic example right now is Invisalign. They're a very popular retainer company. They're all entirely 3D printed. It's a complex shape customized to the user. It's the ideal use case for 3D printing. So when we talk about 3D printing for foods, we're going to be talking about its applications in a wide variety of different fields that I mentioned here. And we're going to look at it through the lens of this 3D printed dinner we did for the New York Times. So the first one is prototyping. Prototyping is a very useful tool for 3D printing. It's what it's originally been used for. So here we have a nice wine glass that's in the shape of a Roman column, entirely 3D printed and done using a plastic printer on the desktop. The man designed it for his Italian-themed dinner and printed it right in his own home. And so you can do customized iterations on these designs relatively quickly. You can even do entire place settings here and silverware and iterate through designs relatively quickly for marketing purposes. You can also use it for low-cost injection runs. So these are molds that were 3D printed on a Stratasys Object Connex printer, and they can be used for producing parts and food-safe materials relatively quickly on low production runs. So if you have an idea and you want to try it and you're not sure if you need to commit to making high-end steel tooling, you can try it out with a 3D printed tooling. And of course, you can do functional customization. So for instance, these here, this artistic designs were entirely done, which would be very difficult to do any other way unless you did casting, which is very hard to do if you want to service a small market. And you can also do functional customization by, for instance, these designs here are designed so that the part that goes in your mouth never touches the ground, so you can service the germaphobe market. You know, it's a tiny market in the United States, but it's serviceable because you can 3D print the parts. My personal favorite is this bowl here. It's designed to enforce good etiquette at the dinner table. It's customized based on the density of the soup you're eating, so that as you eat the soup, it eventually tilts the bowl away from you, because in America it's considered good etiquette to scoop away from you when you're eating the last bit of soup. So it automatically enforces etiquette by its shape, and it's customized to the soup that you're eating for that particular meal. And again, geometric complexity is where it all comes down to. If you're introducing 3D printing into your food processing plant, you can build high capacity heat exchangers that work far more efficiently because of this added geometric complexity. So if you can extract added value from a complex shape, it's an ideal target for 3D printing. So next we're going to talk about is 3D printing food and 3D printing food directly. There are kind of three schools of thought on 3D printing food. The biological school of thought, the bottom up and the top down. Biological is best summarized by this company Modern Meadow. They use bioprinting techniques to 3D print tissue, specifically meat, for human consumption. Right now they can produce an entire hamburger on their 3D printers. It's delicious, I've been told. Unfortunately, it's relatively expensive at $100,000 a hamburger. But the goal is to have it so that you can produce cells more efficiently than a cow and make tissues and batch processes without needing to ever raise farm animals. I personally don't know if this will ever work, and I personally do not think I will ever eat it, but it is one of the growing schools of thought in 3D printing. There's also TNO in the Netherlands, who's looking at bottom-up 3D printing, and their goal is to take high energy-dense sources of proteins and fats and carbohydrates and synthesize complete foods from them using hydrocolloids and flavoring additives, so that you can replicate foods at relatively high efficiency and relatively high nutritional density. And then there's the group that I subscribe to, which is what I call top-down, where you take real foods and 3D print them. Examples that seem to be very popular is chocolate. So TNO in the Netherlands 3D printed this chocolate dome with fillings on the inside. University of Exeter's pursuing it. 3D Systems and Stratasys both seem to be pursuing it. Stratasys won't talk about it, but they have 2 patents that are published in the United States on it. And NASA is actually funding a lot of research into 3D printing food as well. Some of the early work we did with 3D printing food was done with the French Culinary Institute in New York City, where we 3D printed, here you see scallop and celery in different forms, and we made a little house, and because it's America, we deep fried it, because that's what we do. And we were able to 3D print all kinds of other complex shapes and deep fry them, and it was all made possible because of flavoring additives and because of gelling agents, for instance transglutaminase, which helped rebind the powders that we used to make the food. We also can work with traditional foods. This is an unmodified recipe for Austrian sugar cookies. It looks like any other cookie until you slice it down the middle and there's writing on the inside. And the goal we're working with researchers is to scale this up so that the next wedding cake you see will have the silhouette of the couple across each slice. But we've also been able to customize some of the artistic aspects of food as well. So we were able to 3D print dough, and using hydrocolloids, which will be talked about later, we 3D printed the sauce and the cheese and made an entire pizza in the shape of Italy for our Italian-themed dinner. And others are starting to come into 3D printing for food as well, specifically for artistic purposes. So all of these, except for this, are from 3D Systems on their ChefJet machine, where they can produce full-color 3D sculptures entirely out of sugar and flavoring agents that are entirely edible. And their market right now is the bakery market, so that you can produce high-end wedding cakes and desserts that are entirely customized for artistic purposes. You also have healthcare nutritional customization. That's something we're working on. It's kind of hard to see in this diagram, but we made an algorithm that, looking at your activity level for the day and your medical records, can automatically determine your caloric deficits, how many calories you have left over at the end of the day, and then print you a cookie customized to your nutritional needs. So it gives you 10% of your caloric deficit back as a reward. We did this experiment with myself and Professor Hod Lipson, and we used our data from Google Calendar and our medical records and printed 2 different cookies. One has diet layers in black and full sugar layers in white. If we didn't add the coloring agent, you wouldn't be able to tell them apart. And so we can customize the complete nutritional content of the food using the 3D printer, because it gives us access to the food at all levels of production and is an automated process for producing food. I won't tell you who got the diet cookie. That's a trade secret. We can also use it for controlling texture of 3D printing, because again, it's a layer by layer process. You have access to the insides of the food. So we're able to use this corn dough, it's a masa corn dough, and 3D print in this new texturized fashion, so you can deep fry it all the way through. And you can control the porosity of the material as well as how much it crunches versus is savory, using the printing process to control the shape of the food as it's coming out. So 3D printing has really found a wide variety of applications in the food industry, and it's really just at the beginning stages. So we're starting to understand what we can do with it. And one of the early commercial applications that's at the industrial scale is from this company BioZoom. And they're using it to control texture in a different way. Instead of making a more complex texture, they're actually simplifying it for elderly. And it's likely to be the first application to go to wide-scale use. This is funded by the European Union. They have a €3 million grant to develop this with TNO. And it's food that is completely smooth so that the elderly who have problems swallowing can't choke on it. And I think this is going to be one of the big first applications of 3D printing food. So using flavoring agents, gelling agents like gelatin and other hydrocolloids, they can replicate a wide range of foods in both flavor, smell, while eliminating the texture component so that it's easy for the elderly to digest. So if you want to learn more about this, I'm going to plug my professor's book. It's been translated into Chinese. But I'm also going to talk about where we see 3D printing going as a field. So some of our research at Cornell has been looking at advanced applications for 3D printing and how we deal with complexity and how we deal with the added need to customize food and all kinds of other devices using 3D printing. And so the problem of customization is that users need to be designers, and most CAD packages aren't up for the task. And so what we see as the solution are fab apps, little applications just like the applications on your phone that will enable you to customize the shapes of things that are 3D printed. So in this example, it's a toothbrush. You can customize the length of the handle, the width, the shape, the number of bristles. But you can also imagine doing this with food products, where if you have a food printer, you can control its savoriness, its sourness, its texture, and its nutritional content. And we're also starting to see data mining the user as an important way to get information. So this is a 3D printed cast that was done. Unfortunately, it'll never see the light of day in America because of our insurance companies, but it's a nice way where you can extract data from the user and customize it directly to them. And this trend is being done more and more with 3D printing, and I see it as a way of 3D printing with food becoming useful. We also have been working on data mining users over the internet. So this is a website we call Endless Forms, where users can go online and just click shapes that they like, and they change form. So if you click a lamp, it gives you a whole bunch of new versions of lamp. You click the next one, it gives you a whole nother iteration. And so it can automate the design process by just having users tell you what they like and what they don't like. And now we're working towards, and they can of course be 3D printed out, and we're working towards automating it, where we just use eye tracking data to customize the designs of things and then 3D print them out. In terms of how we get this complexity, the answer is genetic algorithms. So we use evolutionary processes on the back end, and we can start with a set of design constraints and automatically generate a solution by doing trial and error thousands of times in a computer simulator and using evolution as the guiding tool. So this should be another video of how we use evolution to do design. I'll have to send it out later. But here you can see we used it to control the bending of a beam. So you can control the bend of a beam by setting the profile, and it automatically mixes materials together. So this is a powerful tool in engineering that we hope to leverage into the food industry. And more recently, IBM beat us to it, and they used their new Watson platform as an automated chef to generate recipes. And you can do all kinds of interesting things by tiling foods together and tiling different shapes together to give you complex textures and flavoring. And we hope to explore this in the future of 3D printing. So thank you very much. And if you have any questions, please let me know.
Hello? Thank you. Do we have any questions?
Thanks very much for that. Just a couple of questions. With regards to the actual example, that printing of the hamburger,
Yeah.
How long would that take?
So that's a very good question. The hamburger, it depends on what you call the process. From cultivating a cell to hamburger on a plate, that probably takes about 6 to 9 months. But most of that is incubating the cells on the back end in order to grow them to a large enough quantity. The actual direct fabrication can be done in a matter of hours.
And as an ingredient supplier, what sort of challenges do food 3D printers have, and where should the ingredients be concentrating on? Because obviously these chocolates, for example, I mean, what's being fed into that machine is a base chocolate, or it's the ingredients to make chocolate that then are being converted into chocolate? Like, well,
So
what's actually being put into the machine?
Right. So generally, it can vary over a very wide range. So the bottom-up group are looking at just pure powders. It'll be mixed on demand and produced. So you feed it vitamin A concentrate, vitamin D concentrate, pectin, gelatin, etc., and then synthesize from there on the machine. For the top-down food, you can get as close to source same day locally at your local farmer's market in America and do it. And actually, we did the cookie project because when we first came out with the 3D printed food, there was this reaction in America of this is Frankenfood and the ultimate processed food, and it's disgusting, and you should see the hate mail I got. And so 5 Jewish guys sat in a room and we said, what's the most wholesome thing we can think of? And we came up with Christmas cookies. And so we 3D printed the Christmas cookie to show 3D printing food can really, it's a processing tool. It can run the gambit from fully produced local foods to highly processed powders and concentrates.
Very interesting, thank you.
Yeah.
Is there any other questions? Yes, definitely a very exciting technology, particularly for the customization point of view. And I'm sure a lot of ingredients companies are particularly excited in China about their options with 3D printing. Thank you very much.
Thank you.
So I'm going to introduce our next speaker now, who's also going to talk about 3D printing. I'm going to introduce Lan Tao Wong. So Mr. Lan Tao Wong from Stratasys.